Hello everyone. Today we'll look into regularization, namely L1 and L2. For this we'll use the empty cars dataset, on top of which we'll build a linear regression model, followed by a linear regression model plus L1 regularization, and then a linear regression model plus an L2 regularization. Then we'll check if at all the performance is increased or it changes if it is regularized. For this, we'll use the empty cars dataset, as I said, in which the miles per gallon is my predicted variable and the rest are the predictor variables. So y would be miles per gallon and the rest will be the x's. So for this particular exercise, we wouldn't go into the pre-processing steps much, though this notebook will be the link for this notebook will be attached, which will contain all the pre-processing steps as well. But for sake of the video, we'll cut it short and we'll start with the model building directly. So we run all the pre-processing steps. So first we'll build the simple linear regression model, rather the linear regression model. So we see the coefficients of various variables like cylinder, displacement, horsepower, weight, acceleration, model and origin. So we see the various coefficients and all of them have quite a good participation in the model, leaving out acceleration, which is not much, but other than that it is quite a lot. So the coefficients are relatively uniformly distributed, relatively, and it is a smooth model. Now what we'll do is we'll use the ridge model. So what is ridge? So ridge is basically an L2 regularization. What it does is it adds the sum of adds a factor of sum of squared coefficients in the optimization. So basically it becomes RSS plus alpha, a coefficient, into sum of the squared coefficients. Over here alpha is the parameter which balances the amount of emphasis given to the RSS versus minimizing the sum of squares. So if alpha equals to 0, it will be basically a linear regression model. If alpha equals to 0, so it basically becomes RSS, which is a linear regression model. Again, if alpha is very high, all the coefficients will be 0, because it will be like too much emphasis will be given to the weightage of the squared coefficients. So it will become to 0. So a value of alpha in between 0 and infinity is the regularization, or is our objective to keep a value between 0 and infinity. So in this case, we'll keep alpha as 0.3. Now we see the coefficients. Again, the coefficients are smooth and more or less comparable to the previous linear regression model as well. More or less comparable, as we can see, a bit different but more or less comparable. and this model is also a smooth one. Now comes lasso regression, or L2, or L1, my bad, L1. So lasso stands for least absolute shrinkage or selection operator. Now what it does is basically RSS plus alpha into sum of absolute value of coefficients. So it's not a square term. So again the same thing, if alpha equals 0, that's basically becomes the linear regression model, and alpha becoming infinity, basically all of the coefficients become 0. So over here, when we see, quite a few of the coefficients become 0. Over here 3R to be 0. What does it mean? This is the primary difference between ridge and lasso. Lasso reduces the coefficients of the least important variables to 0. That is, it feature selects. It selects the features which are important, whereas ridge does not reduce it to 0. So L1 can be used for feature selection as well. This is an added feature of L1. So dimensional reduction is possible using L1. Now let's compare this course a bit. So we see for the linear regression model and the ridge model, these scores are identical, relatively identical, almost. But we see a change in lasso. It is changed, it is different. So we see the performance of lasso has gone down, but it uses only 5 dimensions. In case of the other two, it was 8 dimensions. So it is more feasible. Now let us have the polynomial features to understand the region lasso better. So here are the coefficients for the simple linear regression model, simple linear polynomial model basically. Not, yeah. Here are the coefficients for the ridge, which are more or less similar to each other. Now here are the lasso coefficients, which are quite different than the previous two. So over here we see lasso, the accuracy is relatively similar. It reduces a bit but not drastically. It is similar. It's like it's very similar to the one that we used ridge, but the catch over here is it gives a similar accuracy but with half the number of dimensions. So lasso is used for dimensionality selection or reduction or feature selection as well. So this is all for today. The link of the notebook will be attached. Hope you enjoyed it and liked it.